Next, we're going to take a look at the last two properties of exponents. The first one is a review. We may be using that one again. Remember, anything to the 0 power equals 1. We went over why that works in yesterday's lesson. So we'll start with going over why the next rule works. This is called a power of a power rule. I'm looking at rule 4 here, where a to the m to the nth power. So we're taking a power and raising it to another power, and we multiply the exponents in this case. So let's remind ourselves why this works. If we have x squared cubed, it means we're going to take x squared and multiply it by itself 3 times. We can either use the power rule that we learned yesterday, where we're going to add those exponents, or we could further expand each of these as x times x, and we see that we're multiplying x by itself 6 times. And our last rule is the negative exponent rule, and this one's the most challenging one to remember. So as I'm going through this, think carefully about what I'm saying and why this rule works, and hopefully you'll be able to remember it. So we're going to think about this one 2 ways. The same way that we thought about the a to the 0 equals 1, we're going to set this one up in a similar way. Let's say today we have x squared divided by x cubed. If we write this out the long way, we've got x times x in the numerator and x times x times x in the denominator. So again, just like we saw our dividing rule yesterday, 2 of these x's cancel. And remember, when you divide something by itself, it equals 1. That's where the 1 in the numerator comes from. And we have 1x left in the denominator. Another way to think about this rule is using our dividing rule. Our dividing rule is we can subtract those exponents. We saw why this rule works yesterday. So 2 minus 3 gives us -1. So x to the negative first power equals 1 over x to the positive 1 power. So when we have a negative exponent, we flip it and the power becomes positive. If the negative exponent is in the denominator, you flip it to the numerator and the exponent becomes positive. Our essential question is the same as yesterday. We're spending a couple of days on our power rules, so we're still thinking about why these rules work. Starting off, we've got a basic power of a power rule. In this case, make sure you distribute that 5th power to everything inside the parentheses. It's really tempting to ignore that 2 as being part of the parentheses and just distribute it to the power, but that 2 is being raised to the 5th power as well. So I'm going to write this out the long way, and then we have d to the 3 times 5 power. So this is our power of a power rule. Remember, we just saw we could write d cubed times itself 5 times, and we'd end up with 15 d's being multiplied together. Now I'm going to take a look at that coefficient, 2 to the 5th power. 2 times 2 is 4, so that's 2 squared, times 2 is 8, so that's 2 cubed, times 2 is 16, that's 2 to the 4th, times 1 more 2 gives us 32, so 2 to the 5th power is 32, and then we have d to the 15th. This time, if you look at part B, the coefficient is outside the parentheses, so we do not raise it to the power. Remember order of operations, grouping symbols first. So we're going to take a look at what's inside, and we're going to distribute that 10th power to everything inside. Again, as a reminder, our power of a power rule, we multiply the exponents. So 7 times 10 gives us 70, and 8 times 10 gives us 80. Then we can go ahead and multiply by that coefficient. Essentially, we're just dropping the parentheses. So we get -6 q to the 70th, r to the 80th. Common mistake I see here is students want to distribute that -6 to the q and the r, but this is not q plus r, it's q times r. So we're really multiplying everything all together. And in multiplication, you can multiply in any order. We typically organize with the coefficient first and then the variables in alphabetic order. It's not wrong if you write your variables in a different order or if you throw your coefficient in a different order, but it's much easier to read the term if that coefficient is first. And then we just like to organize things, so we put it in alphabetic order.